Okay, so today we're going to be looking at some exponent rules. The first example that we have is 3x to the power of 2, or 3x squared, times 2x to the power of 4. So real quick, just to remind you of the anatomy of these terms, anytime you have a number multiplied in front of a variable, it's simply called a coefficient. So the 2 and the 3, these are coefficients. The terms that are raised to an exponent are called bases. So the x here and the x here, these are called bases. Any term raised to an exponent is called a base. And then the exponents themselves are the numbers, they're little and they're up at the top next to the right-hand corner of the bases. So 2 and 4, these are what we call exponents. Okay, so when I use the term base, you know I'm referring to the term that's raised to the exponent. Okay, so let's go ahead and begin simplifying this. First of all, lost my multiplication symbol here. Let's rewrite this, reminding ourselves of what an exponent is. All an exponent is a number that tells you how many times to multiply the base by itself. So 3x to the power of 2 could be rewritten 3 times x times x. Okay? It just means multiply x 2 times. So we have x times x. 2x is being multiplied. All right, we'll bring down our other multiplication symbol here. I'm going to write it in a different color to distinguish. And then let's rewrite 2x to the power of 4. That would simply be 2 times. How many times are we going to multiply x on this side? 4 times, because the exponent is 4. So I'm going to write 4 x's being multiplied. X times x times x times x. Okay, now it should be pretty easy to see how to simplify this at this point. We all know that you can multiply the coefficient 3 times 2. 3 times 2 simply gives you 6. So I'm going to write that down. And then I have how many x's being multiplied all together? 1, 2, 3, 4, 5, 6. So if there's 6 x's being multiplied, you could rewrite that as x to the power of 6. Okay? So just let's go back to what we did. We rewrote 3x squared as 3 times x times x, and we rewrote 2x to the 4th as 2 times x times x times x times x. 3 times 2 gives us 6, and then we realized that since we had 6 total x's being multiplied, that's the same thing as x to the 6. But notice, this takes a little bit of time and a little bit of work. So if we could find a shortcut to eliminate this step of writing it all out, that would be really good. Well, if you notice here, from the beginning, the two exponents were 2 and 4, and our final exponent was 6. So if you ask yourself the question, what could we do to the 2 and the 4 to get 6? You might realize all you have to do is add them together. 2 plus 4 makes 6. So without even using this middle step here, we could have just right from the beginning said 3 times 2 gives me 6, and then my exponent is an x, my base is an x, add the two exponents together, 2 plus 4, and that also gives me 6. It's just it's a coincidence that these two numbers happen to be the same. That's complete coincidence. Okay, so let's establish a rule here for multiplying. This is called the product rule. The product rule simply says when you multiply same bases, notice they have to be the same. So in our last example, the bases were both x's. So if the bases are the same and you're multiplying, you simply add their exponents. Okay? So the product rule says when you multiply same bases, you add their exponents. Let's do a few more examples. In this example, we have negative 4a to the 5th times a to the 7th. I could rewrite the whole thing the way I did before, but now that we know the product rule, we can save ourselves that trouble. So let's simply multiply the coefficients and add the exponents. Well, notice we have a coefficient of -4 in the first term, but the second term doesn't have any coefficient. So do you know what the coefficient would be if it's not listed? There's actually an invisible 1 there, because 1 times a to the 7th is still a to the 7th. So I can write that in if it makes it easier to read it. -4 times 1 is -4. I write down my base of a, and then what do I do with the exponents? I add them. 5 plus 7 equals 12. So that's my simplified expression, -4 a to the power of 12. Let's try a little bit of a trickier example. Make this a little bigger for you to see it. Again, it looks like a big mess, but all you have to do is take your time, multiply the coefficients, and then add the exponents for the same basis. So -9 times 3, we'll start with the coefficients. That gives you -27. My first base is an x, so I'm going to write down an x, and I'm going to add the exponents for that base. The first x has an invisible, what number? An invisible 1. And the second x has an exponent of 2. So it's x to the 1 times x to the 2. We add the exponents. 1 plus 2 equals 3. The next base is a y, so we write down y. We're multiplying, so you add the exponents. 6 plus 2 equals 8. And then the last base is a z, so we put down the z. Add the exponents. 4 plus 10 equals 14. So you see, it's actually not that difficult to simplify these terms just by following the rule and applying it step by step. All right, I want you to try this one. I'm going to give you one more problem on this video, and I'd like you to pause the video after I give it to you and attempt to work it out yourself. If you get stuck, just play the video and watch how I do it. When you finish the problem, if you're able to work it out by yourself, then play the video and check your answer and see if you got it right. Here's your problem. Get that down here so you can see it a little bit better. 1/2 p to the 3rd q squared r squared times 6p r to the 6th. Go ahead and pause the video and then play it either if you need help or to check your answer when you're done. All right, let's go ahead and go over this problem. First, we're going to multiply the coefficients. 1/2 times 6. Well, what's 1/2 of 6? If you have 6 pencils and I take half of them, there's 3 left. So 1/2 of 6 is 3. My first base is a p. So I write down my p. And what do I do with the exponents? Well, since we're multiplying, you add the exponents. 3 plus, what's the invisible exponent with this p? The invisible 1. 3 plus 1 is 4. Write down my next base. It's a q. Add the exponents. There's a 2 here. Sorry, I'm jumping the gun here a bit. And there's no q's over here, notice. So we're just left with the original q to the 2nd. There's no q's over here to add on to it. And then finally our last base is an r. So we have 2 here and 6 here. We add the exponents because we're multiplying. 2 plus 6 equals 8. So your final simplified answer is 3p to the 4th, q to the 2nd, r to the 8th.